Hello everyone, and welcome to our Make the Web Fast series on Google Developers Live. Today we're going to talk about an awesome new image format called WebP, and with us today we have Stephen Koenig from the WebP team.
Great. Thanks, Ilya. It's great to be here and update all of you on what we've been working on with WebP and hopefully convince you that it's a great alternative.
So speaking of convincing, let's get this right off the bat, right? Like, I'm a busy person, I'm a developer, I got features to build, code to write.
Right.
Images. Why should I care about images, first of all? And second of all, I have a buddy designer who's great. You know, he does awesome work, and he tells me that he's optimized his images. I'm not sure what he's using, but I trust him. So why do we care?
Why do we care? One of the reasons we care is that images make up a huge proportion of the amount of bytes that we send in most web pages, and I think we've got some data to talk about that. But if we're looking at ways of making the web faster, it's one of the most obvious things we need to look at as far as how we can optimize. And in terms of image optimization, there's lots of different aspects to that. But ultimately, it comes down to how we can produce the smallest size for the best quality. And we think WebP offers some unique advantages in that way. And we think it plays an important part in how people use the web.
Interesting. OK. So speaking of data, right? So as we were preparing for this presentation, I checked some data on HTTP archive, and I specifically looked at mobile, because mobile is an exploding topic, traffic going through the roof. So this is data for across a couple of thousand of the most popular mobile sites, right?
Yep.
And when I look at the overall size of the page, first of all, an average page is about 700 kilobytes.
Yep.
So it's actually a little bit less than a desktop version, which is good news.
Right.
But then when this number actually shocked me, when I look at the breakdown between the different content types, images are basically 70% of the data on the wire.
Yeah, that's pretty typical. It's actually a little bit higher on mobile than what we see on desktop, but it's the fact that it's the single largest component of the page size is very consistent with what we see across desktop as well. The other thing I noticed for mobile, in addition to just the raw bandwidth we're consuming, typically users are more bandwidth constrained on mobile than they are on desktop, and in some cases having to pay for that. So think about it from the perspective of what you're asking your users to pay when you're designing your web pages, and images are such an important and sizable component of that.
I would love for my browser to have like a sidebar on the side saying like, you paid this much to
here's
download
how much
this
you spent.
page.
Exactly.
We should build an extension for that. That would be awesome.
Yeah.
And then I guess the other thing to point out, especially in mobile today, right? It's become a high DPI world.
Very much so.
And in fact, it only recently occurred to me that we really need to kind of shift the conversation away from like, should I be doing high DPI, towards basically every device you buy nowadays is high DPI, right? Certainly maybe a year ago or year and a half ago, it was still a novelty item, like you had to pay extra to get your Retina experience kind of thing.
Yep.
And today, like if you look across the board, you're getting high DPI devices no matter what.
Exactly. Yeah, they're definitely proliferating, and I think as users begin to experience these devices, they don't want to go back. So we're gonna see increasing demand on the part of consumers for more high DPI devices. And the unfortunate thing is, most images today are designed for a low DPI environment. So when you translate those to high DPI, they don't look so good. And so it's putting a lot of pressure on publishers to update their sites and their images to look better on these high DPI devices.
Right. And that's a really hard one, right? Because to your point earlier, my bandwidth has not gone up magically by 4, right?
Exactly.
Or latency decreased by 4, but all of a sudden the images are getting 4 times bigger.
Exactly.
And I think actually the 4 is worth explaining, right? When we say high DPI, we usually mean like twice the size of the image, but you need to remember that it's twice the width and twice the height, which means 4 times the pixels.
Correct.
So if we just take whatever we were doing and apply it to high DPI images, we're going to get file sizes. Instead of 600 kilobytes for mobile, it'll be several megabytes.
Exactly, and that's just even at the same quality level. So if you're using a lossy format like JPEG, in addition to that, what you're probably going to see is a demand for higher quality images with fewer compression artifacts.
Right.
So that in itself will also play a part in increasing the size.
Right. So there's probably like no magic bullet to say like, we can have both high DPI and a lower file size, but perhaps there's a middle road somewhere in between. Right?
Exactly. Yep.
Such that it's not just a 4x across the board.
Correct.
And I guess the other thing that I find, right, when I talk to a lot of developers is just picking the right image format is actually a challenge. Right?
It is.
So as I mentioned earlier, when I talk to a lot of web developers and designers, they say, well, great, I took my image, I optimized it. Like I say there's a JPEG or as a PNG, and I ran it through some tool that optimizes that format, which is great. Except that you're probably optimizing the wrong thing, right?
Exactly.
So picking the right image format is actually a very tricky problem.
It is. You have JPEG, which is quite common, but you have PNG for lossless. You've got GIFs for animation, and unfortunately, we see still some confusion among some developers in terms of what those different formats and how they should be used and what context you should use them. So we see things like people taking JPEGs and then recompressing them as PNGs.
Yep.
So you have a nice lossless representation of your lossy format, which really doesn't help so much in the end. But it does sort of put you as a developer in the position of having to understand what are the characteristics of the different image formats, when should I use one over the other, and how should I mix and match those.
Yeah, and I should mention that this is actually one of the core optimizations that we have in our PageSpeed product. So
Yep.
Mod PageSpeed, Nginx PageSpeed, and PageSpeed Service,
Yep.
where we take the image that you provide us with, whatever that may be, JPEG or PNG, and then we actually try to transcode it into other formats in the background. And then we figure out that, hey, this image file is actually much better compressed if we use a JPEG, for example.
Correct.
Right? So we don't assume anything about your decisions.
Yep.
And it sounds like WebP could actually be the one to kind of rule them all, if you will.
That was part of our goal for WebP, is finding a way to encompass the different kinds of attributes that you want to see from your images, and offering you one format that you can use across the board and to support those different kinds of use cases.
Right.
So whether you want to do a lossy format, whether you want to do lossless, whether you want to do animation, you can do all of those with WebP. And so now you don't have to sort of face this choice.
Awesome. Yeah. So maybe a little bit about the history. Where did it come from?
Sure.
What is it?
Yeah, so we launched WebP, we announced WebP about 2 years ago. It's actually derived from the WebM video format. So it derives from VP8 video codec. So it's basically taking a keyframe from the VP8 video codec and using that as an image representation. So it is fully open source, royalty free. All the source code is out there. All the libraries are out there. It's free to use, free to deploy. No issues there.
Right. Yeah. And actually, just a quick tip. Last week, we had a great episode on WebM and some of the future of WebM with the VP9 work that the team is doing at YouTube and all the rest. So if you're interested, I really recommend just going back in the history for GDLs and checking that out.
Yeah. So just a sort of little brief history on the timeline. So as I mentioned, we sort of did an initial release and launch of that back in 2010, which initially just had support for lossy compression. In October of 2011, we followed that up with support for color profiles and XMP metadata. Last year, we added lossless, which was the support for sort of PNG type formats, as well as transparency. And in terms of what we're working on, we've actually got a couple things coming that are really exciting. You'll actually see a new release coming out in about a week or two that will
Awesome.
add support for animation and metadata. So that will replace sort of the GIF use case. Longer term, we're looking at ways of improving performance on the encode and decode side. So we're always looking at optimizations we can do there.
Right, and I'm actually going to talk.
I want to talk a little bit about that.
Yep.
Better support for ARM and mobile. So those platforms are supported today, but there's work we know we can do to make them even faster. And then in the future, we'll be thinking about things like adding support for layers, so for 3D images, as well as high color depth images.
So just before, I guess, the GDL, we were joking about, like, we have the high DPI, right?
Exactly.
Then we're going to get to the 3D images in high depth.
In high depth color depth, exactly. Exactly.
This sounds like a disaster from performance. It's going to be beautiful.
It's going to be absolutely beautiful, and we're going to work hard to make it performant too.
It is going to be a beautiful web. So a couple of questions, actually.
Yep.
What is the difference between XMP metadata and the metadata support that's coming up?
So the XMP was sort of basic metadata. What we're doing, with the release that's coming up now, is adding additional properties and support, very similar to what you find today with JPEG.
Right. Okay. And just to clarify the difference between lossy and lossless, right? So originally it was basically competing with JPEG.
Correct.
Right.
Yep.
And with lossless, we're saying you can also now use WebP for cases where we're using PNGs.
PNG before.
Right.
Correct.
Not only that, but we also support the alpha channel, which is the transparency in your images.
Correct.
Right. And really up until, so I guess GIFs also had transparency.
Yes.
Right? So, but you kind of had this like weird choice, like for photos, I'm going to use a JPEG. For lossless, I need to use PNG. But if I want animation, I need to use GIF. And now, at least in theory, we should be able to get all of these capabilities in one.
Correct. And I think the challenge there, too, is that each of those different formats introduces its own sort of pluses and minuses.
Right.
And, GIF and JPEG behave very differently from an artifact perspective. And so, it sort of required the web developer to be sort of aware of all those things and understand, what are the implications using this format over that format. With WebP, you get one common characteristic set of properties. So I think it's a lot better.
At least in theory, in the long term, right, as a person who's authoring this content, as a designer, for example, it it actually makes my job a lot simpler.
Correct.
Like, I just save it as. I'll probably still need some toggles to say like this is the use case I want you to optimize it for.
Correct.
Or does the encoder actually figure that out by itself?
So we certainly have a variety of knobs and switches you can tune on the encoder. I think you still need to understand whether you're targeting a lossless or lossy kind of use case, and you need to look at sort of quality levels depending on the use case you have if you're doing lossless, but or lossy rather. But definitely the case that you're using one sort of image encoder with a common set of characteristics, I think helps a lot.
Yeah. Yeah. Okay. Awesome. So some results.
Yeah.
So these are studies that were done back in 2008, or have these?
So these are actually studies that we did in 2011 and 2012.
Sorry, 11.
Yes, 2011, 2012.
We
didn't have WebP in 2008.
Yes.
No. So we've done a bunch of studies and analyses to do comparisons between WebP versus JPEG and PNG. So on the left, what you see is a comparison of WebP to PNG. So the green line is basically this chart is a representation of the ratio of the WebP file size to the PNG file size. So the one is PNG. Obviously, it's just a ratio of 1.
Yep.
And then for WebP, we have two versions of that: one with alpha and one with lossless. And obviously, what you see there is that for almost all images, the WebP is significantly smaller than PNG. There are a handful of cases, less than 2%. Where it's slightly higher than 1.
So that's this peak
that's
right
that little
here.
peak right there.
Right.
But overall, across, in this case, 1,000 images, 98% of them were smaller, and in most cases by a significant degree, than PNG.
So it seems like, especially for lossy with alpha, right? If I look at kind of half of the distribution here is like, it's significantly less.
Yes,
like
you're looking
80,
at between 70 and 80% smaller.
Right, which is actually representative of kind of the larger number that we saw, which is if you have for certain images with alpha channel and PNGs, we can get, on average, like 70 to 80% improvement in byte size.
Yep.
Which is huge.
Which is phenomenal.
Yep. Okay.
And on the right, we did a comparison between WebP and JPEG. And there you see, in this case, we're looking at different levels of JPEG quality, so all the way from about 25 all the way up to 90. And the differences in file size. So the red is JPEG, but what you see there is that, again, consistently, WebP is smaller, for each quality level. But what you notice sort of in the right-hand tail of that graph, it's sort of, JPEG spikes up once you get above quality about 75, whereas WebP has a much more static kind of increase in file size.
Yep.
So what that really tells you is that as you get higher quality images, which harkens back to what we were discussing before about high DPI, the differences, the gains you're getting from WebP become even more significant.
Right. So I think it's worth pointing out that it's kind of it's a nonlinear relationship between quality and file size, right? You get the most benefit on the high quality.
Correct.
And then it kind of decays, if you will, or the gains actually decrease.
Correct.
So if nothing else, going from a JPEG or WebP from quality 100 to 90 is going to give you more benefit than going lower. Like you should consider going lower,
right?
But you're not going to get as much.
You get diminishing returns as you go lower in quality.
Right.
Yep.
Right. So I think that's a point worth just pointing out. And maybe just one more thing, right? So coming back to these tails, I think right before the show we were talking about, so one of the cases where this could happen, because if you're curious, like why would WebP ever be bigger, is actually for very small images.
Correct.
Where the actual container of WebP file is larger than the image itself. Like we're talking about 1 by 1 pixels, and silly things like that.
Yeah, exactly.
Yeah. So if you're serving 1 by 1 pixels in high DPI, keep serving them as GIFs.
That's right.
For everything else, use WebP.
Correct.
All right. So another topic that comes up frequently is, great, WebP is smaller, but I hear that it takes a lot more time to compress and decompress.
Yep,
right?
it does.
And that is true. There's no free lunch. Right?
Correct.
More or fewer bytes means we need to spend more CPU cycles.
Correct.
So how big is that difference, and does it affect my web pages, the loading times, and all the rest?
Right. That's a good question. So you're absolutely right. The reason we get smaller file sizes from WebP is because we spend more time doing the encoding work. And so what we typically see on average is that on the encode side, it takes about 10 times as long to encode an image in WebP as it does in JPEG.
So that's with the current.
With the current,
I think this number has actually improved, right?
It has improved. It has improved steadily as we've been developing the encoder and the format.
Right.
And we expect it to continue to improve. We will never get to 1-to-1. Even 2-to-1, 2x is probably ambitious, but we think we can certainly bring this down more into the range of 5x.
Nice.
On the decoding side, we're about 1.4, 1.5 times slower than JPEG to decode an image. But as you sort of note here, one of the things we see is that consistently the high encoding cost, the bandwidth savings, more than make up for the increase in decoding time on the client side.
Right. So I guess there's a couple of points to make here. So first of all, these numbers are decoding on the CPU.
Right.
Right.
Correct.
So there's hardware out there that will do hardware acceleration, for example, for JPEG decodes.
Yep.
Nothing stops hardware from being developed for the same
Absolutely
thing for
not.
WebP. Right?
Correct.
So it's a question of adoption. It's kind
Correct.
of a chicken and the egg.
It is.
The more people deploy WebP, the more incentive there is for device manufacturers and chip makers to actually make this really fast. And once they put it in silicon, this thing is going to be really fast.
It's going to scream.
Right,
Absolutely.
exactly.
Yep.
So there's nothing that stops that moving forward. But then, so there's one case here that I think that's interesting to point out. So it does take a lot more time to encode images. So
Correct.
if I have a service which is generating a lot of dynamic images, and I put Google Maps here, it's a good example, right?
Great example.
Generates a lot of dynamic tiles, customized tiles.
Correct. Yeah. So the important thing to note about the encoding time is that that's a cost you're going to spend once, versus the bandwidth savings you're going to recoup on every single request.
Right.
So in most cases you're dealing with static images, and so to take a little bit extra time to encode your images once is a cost that's easy to pay for.
Right.
There are cases though, if you're generating images dynamically, and Maps is an example of that. They don't have static map tile images. They generate those on the fly based on your request. Where that cost can be pretty significant and can be a barrier to adoption. So we think for the vast majority of use cases out there where you have static content, WebP is a perfect choice. But if you are doing something a little more unique, you do have to factor that in.
Yeah, and as all things performance, the answer is always measure it.
Correct.
Right. So actually, in Chrome DevTools, we've recently added support, or in the timeline panel, you can actually now see the JPEG and I think WebP decoding times within there. So previously that was not available, so you didn't even know, right? And sometimes you'd be surprised, like decoding a large image can take on the order of tens of milliseconds.
Yeah.
Right. So you can actually measure this on your application and figure out if this is indeed a problem for you. But before we get to so we have actually a great study which addresses this.
Yes.
But before we get there, I think that you made a very, very important point, which is it is absolutely true that your mobile device may need more CPU cycles to decode a WebP image versus a JPEG, which that's slower. That's objectively slower. Like we can show that. But the fact that you ship fewer bytes and the image is available to decode quicker on the device actually outweighs the benefits. And in fact, for a lot of people, data compression is a big deal. Data is literally expensive for a lot of people.
Correct.
Right? And that is a huge, huge win.
Yeah, especially in emerging markets, in areas where infrastructure is not quite as quite as built out.
Right.
That's a huge issue for a lot of people.
Yeah.
And so that's definitely something to be aware of.
Yeah, exactly. So this is an awesome case study that the eBay guys did, and actually just recently, I think a couple of weeks ago or last week even, where they looked at a number of suggestions for how do we optimize images, right? And one of the things they considered was WebP. So they set up this test where they basically had just 50 images on one page, and they had JPEGs and WebPs, right? And then they used web page test to show how the page is being rendered, right? So this graph on the left here actually shows you the visual rendering progress. And you can see that WebP actually beats JPEG across the board, such that the images are actually visible quicker. So let me actually switch to this view. And if you guys are not familiar with web page tests, I definitely encourage you to play with it. So let's go to the beginning. Basically, we're seeing a 100 millisecond frame by frame, like as the browser renders it, right? So we start loading images. About half second in, we start rendering something. And so far, it looks like it's they're competitive, both WebP and JPEG. But you scroll a little bit further, like 200 milliseconds later, and you can see that a whole bunch of WebP images have fully loaded, more getting pulled in, etc. So that's what this graph. Oops, let's go back here. That's what this graph here is showing you.
Correct.
right?
Yep.
So yes, we spent more CPU time, but the actual time to glass, if you will, right, like pixels visible on the screen for WebP is better because we're transferring fewer bytes.
Exactly. And I think it's important to note there that what's important for people to measure is what the end user perception is.
Yes.
Right? End users don't care about how much time is taken up in CPU versus how much time is taken up transmitting bytes. What they care about is how fast does this thing load,
right.
And how fast can I see it. And that's where WebP clearly in this example shines. Even though we're spending a little more time in one part of the process, we're spending far less in another, and the net effect is definitely positive.
Right. So hopefully, by shipping fewer bytes and making the decoding faster in the future, especially if we can offload it to the hardware, it's a win across the board.
Correct.
So I definitely encourage you guys. I'll share the slides after, or just go to the eBay Tech blog. I think it's still one of their top posts. And look through this example. So where are we in terms of adoption?
So we're seeing really good progress on adoption. Keeping in mind that we started this a little over 2 years ago with nothing, I think we're making really good progress. So on mobile, I think we have a really great story across Android and iOS. So Android supports WebP today. We added lossy support in Ice Cream Sandwich release, and then our lossy in Ice Cream Sandwich, and the lossless has been added in Jelly Bean.
Right.
In addition, with iOS, we have libraries available. So if you're building a native app for iOS, you can take advantage of WebP in your native app. On the desktop side, Chrome and Opera both support WebP. And then for IE, Safari, and Firefox, we're working with them, and we hope to get them to support it natively in the near future. But in the meantime, there are solutions available. So for IE, you can use Chrome Frame or JavaScript. And then Safari, either a plugin or JavaScript. And then Firefox, we've submitted a patch to Mozilla. We continue to discuss with them about adding support for WebP. I think they're receptive to it. They're sort of waiting for indications of further adoption on the community, which we're making great progress on. So I'm hopeful we'll see that adopted natively there in the near future.
Right. So I think an important point to make here is something we were talking about with the WebP team, which is for the last 2 years, you guys have been focused on developing the format first and foremost, right? It's been basically engineers heads down, like we need these features to meet these criteria.
Exactly.
Right? And we haven't, although we have built some tooling and infrastructure, that wasn't the #1 priority.
Correct.
Basically, we need to get the format to like a place where it fulfilled its role.
Correct.
Right? So, and I think we've kind of arrived at that by the end of 2012.
I think we exactly have, and that's a great way to characterize it. The initial years of WebP were really focused on building out the feature set and making sure that we had something that was a good replacement option for these different image formats. We've done that work now, and so really the focus for us this year is pushing hard on adoption and optimization.
Right. So it sounds like there's a new release coming, literally maybe a couple of weeks away.
A week to two. Yeah.
Okay. All right. Fingers crossed. Right. And following that, I'm hoping that we'll actually invest into more of the infrastructure, the tooling and everything to make authoring WebP easier and deploying it easier.
Exactly. Yeah.
Okay. So we have, I guess, a couple of points to make here as well. We'll talk about tooling in a second, but Android and iOS, right, ready to go. In fact, it's actually probably easier to deploy WebP today on native platforms on Android and iOS than it is on the web.
Correct.
To some degree, although it's still definitely doable on the web, and we will talk about how to do that. There is a kind of a crazy plugin in JavaScript, right? So we talked about slower decoding. So in fact, you can pull in this JavaScript snippet, right, which will do WebP decoding on the client. So if you absolutely must have like a fallback for a browser that does not understand WebP, you can always use that.
Correct. And I think that that's an option that even if Microsoft tomorrow decides to support WebP, that's probably going to be an IE 11.
Right.
And so for some long period of time, you're going to have all these older IE versions that don't. And so even when we get to native support across all these different browsers, as a web developer, you still have to be conscious of the fact there are going to be users on older browsers that can't support WebP, and so you do need a fallback option.
Yeah. And maybe the last point to make here is, so Opera has been supporting this for a long time because they've actually been using WebP. So if you guys are familiar with the Opera Turbo browser, which does content optimization, in fact, one of the main things it does is optimize images. And by optimize images, I mean transcode everything to WebP. Right? And that gives you huge savings, which is why Opera Turbo is such a great browser for a lot of people. Right? Bandwidth is expensive. WebP helps.
Correct.
And then on Firefox side, I've been following the conversation there, and it seems very promising. I think we're going to see something happen in 2013.
Yep.
Especially as we focus more on adoption.
Correct. I think that's really the key thing that they've asked for, and I think we're going to deliver that. As I said, they've been very receptive to it, so I'm hopeful.
Right. So speaking of adoption, right? Google, WebP.
Yep.
Where are we? Are we
our
dog fooding?
Eating our own dog food, as it were.
Yes.
Yes, we are. So as we've talked about adoption, one of the things that we've really been gearing up over the past couple of months, and you'll see us making a lot of progress on this throughout the rest of this year and into early next, is adopting WebP across all Google properties. So we have it adopted across a number today. And in fact, Chrome Web Store launched not too long ago with WebP images. There's a great blog post out on the Chromium blog about some of the results that we saw from that. But literally, we're saving many terabytes per day of bytes by using WebP over JPEG.
Yep.
We were able to cut the page load time by about a third.
Wow.
So it was a huge win for that team, and makes a great case study. Across the rest of Google, we have support today in Gmail, and Drive, and Docs, Picasa. G+ supports it. If you upload WebP, you'll get WebP back. And then we're going to be launching the Google Play Magazine's reader soon. That's going to support WebP.
Right.
So there's a number of things that are supporting it, and we're working actively with a bunch of other teams. So for example, we're working with image search and doing an evaluation and experiment right now. As you can imagine, it's a pretty heavily used production service, so you don't just flip a switch. We have to go through a whole process of validating, that everything's going to work well. But we're working very, very well with that team, and I think you'll see that rolling out later this year.
Yeah. So it sounds like in a year's time, right? If we were to have a 2014 episode of this, looking back, I think we'll look back on all the Google properties and we'll say yes, all of them support WebP.
Yes, exactly right.
That is our goal, or the goal for the team.
That's the goal, and
we're working with all of the
We're working hard.
teams.
Yep, and so far we're seeing great results across the board. So
right, yeah, I think every single team that has deployed it always has a case study for us, which is like we either saved a ton of bandwidth or we decreased page load time. Usually it's both because they go hand in hand.
Correct.
So that's awesome, and I guess it's also worth pointing out that there's actually quite a few third-party services and sites outside of Google that are using WebP today. So one example that I'm most familiar with is, of course, the PageSpeed product. So PageSpeed service and the open source projects, the Mod PageSpeed and Nginx PageSpeed, will actually optimize your images for you if you install it in your Apache or Nginx server. And we have over 300,000 sites that are using these products, right? So the users to those sites are actually getting WebP files.
Yep.
And we'll talk about how that's actually done under the hood.
Yep.
So that's open source, and there are also commercial vendors like Torbit and Edgecast, right? So commercial CDNs, which will do this WebP optimization for you as well. So there's growing adoption for this thing, and I think it very much goes into the general kind of offering of any CDN, right?
Yep.
Like they want to optimize the web for their customers.
Yep.
And optimizing images, as we saw, 70% of the bytes is the #1 area.
Exactly.
Yeah. So I think we're going to see more and more of this. And I think automation is actually one of the easiest ways to get there, which is why, if you haven't looked at something like PageSpeed or Edgecast or one of these products, definitely check it out. So let's talk about tooling and deployment, right? Great. Format's awesome. I got a whole lot of JPEGs and PNGs. How does one go about creating WebPs?
Yeah. Well, the fastest, dirtiest way to do it is to download the libwebp libraries, and you just run a command line and basically give it a whole bunch of source images and some parameter options, and it's going to spit out WebPs for you.
Okay.
So that's the quick and dirty way to do it.
So that's the CWebP, right?
Yep.
So the encoder,
right.
I guess. And if I just want to run this on, like, I have a folder of files, right? Do I need to worry about a whole bunch of knobs? Or do you provide sane defaults? Basically, what should I be considering?
Yeah, we definitely provide sane defaults. If you want to just run it blindly on a bunch of images you have in a folder, you're more than welcome to do that.
Okay.
It's definitely the case that if you want to dive in and tweak and adjust things, you're welcome to do that too. But we try to make it as easy as possible.
Right. So there's actually a couple of tools to experiment with these files, and maybe one thing worth calling out is, for example, JPEGs have their own artifacts when you compress them, right?
Yep.
Like you get funny behaviors or funny look in the image.
Yep.
WebP is a different compression format, which means that you're going to get slightly different artifacts.
Correct.
And those could work in your favor or against you.
Correct. Yeah.
So it's probably worth experimenting a little bit and seeing like what is the quality that, for example, I should be using.
Yeah,
what
definitely.
is acceptable.
Definitely. Well, it's one of the things you want to look at, because obviously with lower quality you get smaller file sizes. So as you're trying to improve speed, that's something you can, a knob you can tweak that will definitely have an impact. But you're right, as you lower the quality, you're going to get more compression artifacts. And the kinds of artifacts you see between JPEG and WebP are different, especially as you get into lower quality levels. So you do need to do visual comparison at that level to understand, is this producing the right, am I comfortable with the kinds of artifacts that I'm seeing in these images?
Right. Yeah. So that's something to experiment with. And I guess the one link, I put a couple of examples here of the different plugins that you can install. For example, the WebP codec for Windows, which was developed by you guys, right? Which means you can just view your WebP files natively, within Explorer and all the rest. There's Photoshop plugins, but first and foremost, actually, the WebP page on Wikipedia has a fairly extensive list of all the tools that support it. So if you're not sure, go there and just search for whatever tool you're using. Right. So that's a good tip. And then the other thing is, if you go on GitHub and just search for WebP, you'll actually find language bindings for virtually every major platform that I've looked for, at least. Right. So if you have a build step or some sort of automation, you can pull that in, and you can actually automate this entirely on the back end, such that you don't even have to worry about it, which is great. And then kind of a fun tool that popped up just recently. So image2webp.net. So this is this is not something that you should use for I'm going to convert all my images using this. But if you're just curious and you want to understand, without downloading the WebP libraries or what have you, you just want to play with it, this is a good tool. So I'll show you an example. I have an image file here. So just a photo, which I saved as a PNG, right? This is my lossless, lossy format, right? Beautiful image. I'm just going to grab it and drag it into this page. And it is actually doing the optimization. So it actually picked a bunch of defaults for me, right? So you can actually click on advanced settings and kind of play with the different filters. So it gives you this .webp file. Let's open that. And that looks the same, so that's good. Oops, we didn't want Gmail. We wanted this. And what I want to see is the file size. So the file size is 42 kilobytes for this file. Let's go back to the original. 837. That's a bit of a difference.
It's a bit of a difference.
Yeah. So this is an example of both picking the right format for the file and also having a format that compresses well.
Exactly.
Right. So I'm sure if we compared a JPEG version to WebP, it wouldn't be as dramatic of a difference. But nonetheless, WebP would give you a nice byte savings. Yeah. So unfortunately, this is a very common pattern. People saving what should be a JPEG, or ideally WebP, as a PNG.
Yes, it happens a lot.
So let's talk a little bit about Android and iOS. We're not going to go into too much detail. As I said, I'm going to share the slides later. So this is more as a reference, right? I just wanted to show that it's actually very simple if you're writing a native app to integrate WebP, right? So we mentioned that Android 4.0 ships natively with WebP support. So you load the library and you decode the image. It's just a bitmap,
Create a
right?
bitmap.
And that's it. That's effectively all there is to it. It's identical to anything else.
Correct.
One thing that's worth mentioning is we shipped native support in 4.0 plus, but there's a great project on GitHub where somebody did a backport, so for the older versions of Android. So you can pull that in if you need to. And there's a lot of older Android devices out there, unfortunately. So that's a handy thing to have. And then for iOS, same thing. You guys actually provide the iOS framework.
We do.
So if you download the library, I guess, right? You can actually compile it, and you get the webp.framework, which you can include in your iOS project, and then go from there.
Exactly.
Right. And if you look at the code, it's effectively the same thing as we saw previously.
Right.
There's a great tutorial on this. If you just search for WebP iOS, there's a couple of great write-ups. And likewise, there's a really nice project sitting on GitHub, which is actually like a pre-built or pre-made app, iOS app, which includes WebP. So you can just download that, build it, run it, see how it works, and adjust it as you need it, kind of thing. So that's the native side. I'm going to claim that one is actually easier.
It is today. You're right.
Yeah. WebP is a little bit on the web is a little bit more complicated, but it's still doable. So there's a couple of different strategies, basically, right? There's client side and server side, and there are cons and pros to each one, unfortunately. And ideally, you probably need both to make them work well, right? So let's work through an example. We have an awesome WebP file, right, which we want to serve. And basically, the difference here is that some user agents, for example, Internet Explorer, does not natively understand WebP. If the user has Chrome frame installed, they will render WebP. But if they don't, they can't today. Same thing for Firefox. So basically, we need to, depending on which browser comes to our page or loading the image, we need to decide which image we're going to serve, a JPEG or a WebP. Right? So this in itself actually creates another concern for some people, which is I also need to duplicate my storage, right? I need to have both files, which is true, right? But we find, at least in all of our case studies at Google, that this is definitely a worthwhile investment because it gives such a better experience to the user.
Correct. And I think the thing I'd point out on that is it's a question of where do we who should be paying the cost, and where is that best paid for? And I would argue that it's better paid for on the part of the web developer and the site author. It's better for them to pay for a little bit more storage and some more memory for the cache than it is to ask every single user who hits your page to spend more time downloading and potentially more money on bandwidth if they're on mobile.
Exactly. And of course, as the adoption grows, this also becomes lesser problem, right? So, for example, for client-side detection, Moderniser actually has a test for WebP. So, if you have your client-side code, you can actually just say moderniser.webp, and then if it's enabled, you can schedule an image download that way. And if the test fails, you can actually fall back even to the JavaScript include, or you can schedule your JPEGs. Right. So either one works, and the benefits of this is it'll work across all browsers. This code will run in Chrome just as well as in IE and everything else. The trouble with this is this actually hides. So because in this example here, I'm actually creating the image tag via JavaScript. It means that I need to download the file or the HTML, download this JavaScript, execute JavaScript, and only then will the image be scheduled. Whereas the browsers today are very, very good at scheduling things as quickly as possible up front. Right. So that's kind of the trade-off that we have here. So that's one thing to keep in mind. It's one strategy. The other is to do server-side detection, which basically means that a request comes into your web server, and your web server looks at the user agent header that your browser sends, and it says, hey, this is Chrome. Chrome indeed supports WebP, so I'm going to serve you this version of the file, which actually has .webp files in it. And this is actually what the PageSpeed and other, like Torbit and other products do. They do this server-side detection, and they actually serve different HTML files, which doesn't incur any of the JavaScript cost, but it has a slightly different negative side, which is because the file itself is different between browsers, we need to declare it as cache control private, which means that this file is private. It can still be cached by the client for however long you specify, but it is private to this client. Right? You can't share this file between all the browsers, which may or may not be an issue depending on how your cache or CDN strategy works. Right? So in PageSpeed, we actually mark the base HTML file as cache controlled private, which means it's cached by the client but not by the intermediate cache. But then all of the images are cached for a year, which is where most of your cost is. Right? Because if we go back to that very first slide that I have, the HTML was there's 40 kilobytes of it, right? And then there's 800 kilobytes of the rest.
Exactly.
Right. So the 800 kilobytes are cached. So pros and cons, once again, take a look at mod PageSpeed or how it does it under the hood, or you can write this function yourself. It's actually pretty simple. Basically, you're saying if user agent is Chrome or Opera, great, serve WebP. So I think that's basically us at the end. Right? So we have a couple of questions, but before we get to the questions, you mentioned some of the things that are coming ahead, right? What can we expect in 2013?
I think, by and large, what you're going to see in 2013 is lots of progress on adoption. We've talked about that. And as we make more progress on that, we're going to be shouting from the rooftops about all the great case studies that we're confident we'll see. And some of the data that we're starting to see already, working with a bunch of internal Google Teams. We're working with one now that does a lot of serving of photos.
I wonder who that could be.
I don't know. I can't imagine who it might be. But in that case, we're seeing upwards of 50 to 60% reduction in image sizes. So you can imagine the kind of impact that has on the user experience.
Right.
And so we're excited about that. We'll hopefully launch that very soon. You'll see many more examples like that. And then alongside that, we're going to continue to focus on optimization, and trying to bring that encode and decode time down even further. But we're at a point today where we're ready to put really push the gas pedal and make some great progress with WebP.
Awesome. Okay, so maybe one more thing to point out before we head to questions is we do have the public WebP Discuss group where you can ask questions, follow up. If we didn't cover something here, or we're not going to get to your question, then just head there and drop us a question. So let's see. So we talked about the adoption of WebP from other vendors, right? So we're working with Firefox. There are plugins for other browsers. There are ways you can basically provide this functionality in there. And then I guess there's user agent detection and a few other things. So there's a great question here about what's the current progress of animated WebP? So it sounds like that's coming in
We talked
weeks.
about that. That's going to be very soon.
And are there any plans to eventually use predictive features of VPA to keep animated WebP small?
Good question. It's definitely something we're thinking about and looking into. There's also going to be improvements down the road to the VP video format. So we're going to be taking a look at those and seeing how we might be able to adopt those as well.
Right. Okay. What is the current process for third-party support? So we talked about it. I'd like to see digital camera and phones saving high-quality photos as WebPs.
Yeah, we'd love that too. I think it's important to understand this is, adoption is a bit of a progression.
Right.
So, today if we go talk to a camera manufacturer, they're going to say, well, why should I spit out WebP images from the camera? I can't upload those to a lot of places.
Right.
So, we have to sort of work this in a stepwise manner. And so getting WebP adopted across the web will make it a lot easier for us to go to consumer electronic device manufacturers, camera makers, phones, etc., and say you really should store this natively in WebP. And the story there is the same. It's, wow, for the same compact SD card that I have in my camera, I get essentially 1.5 or 2 times as many images.
Right. So just to reiterate the example you just gave, right? This that shall be unnamed product, Android product that serves a lot of photos, right? You grab the photo off your camera, probably a JPEG, right? Probably a couple of megabytes at least. They then transcode it to WebP and upload the WebP because it's so much more efficient.
That would be the way to do it. Absolutely.
Right? So, if the camera saved it directly as WebP, that'd be great.
Even better.
But it'll probably take some time before we get there. Okay. So, WebP can be more efficient compression algorithm than JPEG and PNG, but it uses more CPU resources. Please keep that in mind. So that's a legitimate point.
Fair point.
And measure it. Right. We actually have the tools now in Chrome DevTools, so take a look at that. And you saw the eBay example. So there's bandwidth costs and there's CPU costs, right? And it really depends on your application. I think for majority, bandwidth is far more important.
Now, Ilya, we actually got a fun question from YouTube. Josh was asking, because everyone's excited about Project Glass. He wants to know if Project Glass is going to save in WebP automatically to save on mobile data usage. What's your insight into that, and are you going to break something confidential?
As soon as I can start dogfooding a Glass device, I will make sure that's the first feature we put in there. How's that?
Fair enough. So Francois actually asked a great question, which is Chromium, or Chrome itself, right? Actually, internally for all the images and like DevTools and all the rest uses PNG. I guess it's not a question; it's more of a comment. Like, why aren't we using WebP?
We should be, and we're gonna be fixing that. So absolutely.
Okay. Yes, and actually, Adi replied to that and said, "Yes, open a bug about this. We should fix it." So we're on it.
In fact, I opened a bug about this not too long ago, so we'll get it fixed. JNG could have been used to produce JPEG images with alpha channel. Not actually familiar with that format, but I think maybe the point here to make is, I said WebP kind of wants to rule them all, but I actually believe that we need many different image formats on the web. Like we have this artificial limit of 3 today for whatever reason. Like we've all somehow agreed that that's all we need.
Thou shalt use a GIF, a PNG, and a JPEG, and it's like there's no reason for it. Right? We could optimize things much better.
Exactly. And we see this, sometimes when we go out and talk to folks about adoption, they say, well, what about this format or what about that format? And our view is that, there's room on the web for lots of different formats, and ultimately they all should stand on their own and, prove themselves.
Right.
But, we don't view it as an exclusion to other options.
Yep. So is there any way to use WebP in Android less than 4x? Yes, so there's that backport, and I'll share the slides later so you can find the link to it. Wouldn't just using a PNG file be faster than converting WebP with a plugin? I am not sure what this is actually asking.
Well, I guess it depends. If you're using, say Safari with a plugin.
Oh, I mean for browsers that don't support it.
For browsers that don't support it. Potentially, I think again you have to measure that in terms of what is the bandwidth savings from the smaller file size. Obviously, plugins aren't perfect either because they introduce a little bit of user friction into the experience, and they have users have to install the plugin and so on. So that's something to bear in mind as well.
Yep. Okay. So Aaron Peters here. So if you serve static images off a CDN and you want to support all the usual browsers, including all of the IEs and Firefox browsers that don't support WebP, then how to get WebP served off the CDN to Chrome and Opera? So this is a great question, and I think this actually boils down to support at the CDN layer, at the CDN level, at the edge for WebP. So as an example, PageSpeed service, which is the Google-hosted PageSpeed libraries, we actually do the user agent detection at the edge on our edge servers. And actually, that's the same strategy that Edgecast uses. So Edgecast actually uses PageSpeed open source libraries under the hood. They deploy it at the edge. They run this user agent detection, and then they serve the correct file. So unfortunately, that means that the CDN itself has to support WebP. But I think, from my conversations with a lot of the major CDNs out there, it's definitely something that everybody's considering, just because the mobile web is shooting through the roof.
Exactly.
Pages are getting bigger. You saw the number of bytes on the wire. So they're all looking at this in some way or another. So I think we're going to get there. And that's not to say that user agent is the only way to do it. I think there are better ways. In fact, we've been talking about with the Chrome team about fixing some of the accept headers and making this easier, right? Such that you don't have to write these crazy user agent detection functions.
Correct.
Instead, you should be able to look at the accept header and it should say, yes, I really do support WebP.
Right.
Give me a WebP file.
Yeah, that's a great solution in the long term, and I think we'll get there. The advantage to that is you don't have these hard-coded rules about user agents and which ones support WebP, because as more support them, then you have to go change that logic.
Right.
Whereas if you just look at the accept header, if a new browser comes along and supports WebP, great, you're going to serve WebP to it, no change needed.
Yeah.
So we'll get there.
Yeah, exactly.
So Ilya, back on YouTube, Zachary asks about encryption. Would it be possible to encrypt WebP images so nobody could intercept them? 2 examples being profile pictures or personal things.
So the short answer is yes, you can deliver them over SSL.
Yep.
Right, and I think that's all there is to it.
I think that's probably the best way to do it.
Yeah. Unless you guys are working on a secret new feature.
We are not planning on doing any secret new compression algorithms now.
Okay. Yeah. So I think that one's actually pretty simple. SSL. That's the answer there. Compared to JPEG Mini. Are you familiar with JPEG Mini by any chance?
A little bit. I think again, I would just say I think as a site author, I think you need to look at different options and decide what's best for you. I think we're very confident in in how WebP stacks up against alternative formats. But if you find JPEG Mini's a good choice, then that's fine.
Yeah.
We think WebP offers a much better alternative for the vast majority of use cases that are out there today.
Yeah. At the end of the day, make the web fast.
Yeah.
If you make it faster, we're happy. If you use WebP, great.
Yep.
Right? If you find some other magic bullet, awesome.
Yep.
As long as it's faster. I guess a comment from Max: the fire didn't look realistic in that WebP version versus PNG. So maybe, I don't know, right?
Yeah.
But I think this actually points out an important point. It's all about your own decision making, right? And like your art direction.
Right.
So you need to find the right quality level, right? Whatever, I'm not even sure what the default
there were defaults
was.
that were set on there that you probably needed to tweak, right?
So don't just look at like, here's an image, here's an output from some tool I got. There's a whole bunch of knobs, and you can tweak those knobs and optimize for your case, right? So if you absolutely must have certain quality and detail in your images, we give you those knobs.
Right.
We give you, if anything, there's too many knobs. Okay. I wrote a batch script called script WebP. It converts PNG and JPEG files to WebP using CWebP, using simple drag and drop. Awesome.
Awesome.
So,
That's great.
So definitely check that out. What is the adoption rate of WebP format on internet pages? So I shared some data previously about the PageSpeed service, so that's the one that I'm most familiar with. There's over 300 sites using those products today, and they are serving WebP to clients that support it. So that's the ones I know of. There are also commercial vendors that provide the service, so there's a lot of sites actually that are using it. And as we said, we're going to see a lot more Google sites and third-party
sites.
Yeah. Hopes for picture tag. So the picture tag conversation, I think, is orthogonal to this. Right. Picture tag has a lot more other things going for it, and I hope that it'll actually come. I think it's something that we need. It's a question of, can we actually pick some, there are many things that picture tag could be, and we may need to cut some corners and cut out some use cases to actually make it happen. Do we get improvement for black and white images?
I believe so. There's no reason why we wouldn't.
Yep. Google Drive and Android. Will Google Drive and Android support WebP soon?
Yes, hopefully. We will make sure it does.
Okay. So it sounds like you guys are working.
Yep.
So thanks for your answer, but UA detection on the edge, that is part of the CDN's expensive dynamic content acceleration products. Most sites serve HTML off their own servers and static off the CDN, so I guess you need to do the UA detection. Yes. So for example, the strategy that Mod PageSpeed and the Nginx PageSpeed service uses is we generate a different HTML file, and that file contains different links, right? So one contains links to WebP, and the other contains link to, for example, JPEG. And then those files can be just statically synced to any CDN, and everything is fine. So you don't need cooperation of your CDN provider for that. So that solution also has some caveats, but that's what a lot of sites have been doing today, and it is workable.
Yep.
Is the format patent free?
Absolutely.
Yep. So free, open source, BSD licensed.
Yep.
I think if you actually go to the WebM project, they also even give you schematics for building chips, which I think is awesome.
Yeah.
Okay, so I think we've answered everything that's been here.
Yep.
If you guys have more questions, WebP discuss. But otherwise,
one last question on YouTube.
One more.
more.
So Josh loves this show, by the way. So he's asking about Android cameras getting the ability to convert to WebP on the fly if they're running Android 4.x. Maybe they can save in RAW and WebP.
Yeah, I think that's certainly something I think we will see over time. Again, I think it gets back to the challenge today would be if you spit them out as WebP, it would restrict where you could upload those photos today. So as we get more adoption on sites that support WebP uploads, then something like what you're describing makes a lot of sense, and I think we will see that over time.
Yeah. So if your service, if you run the service to where you're uploading, right, and you support WebP. And let's say, so this actually could work, I think, both for native and web apps.
Yep.
So for native, you request your camera, you grab the bytes, right? And then you can
convert them.
Convert that into WebP and upload it directly to your service. You can do the same thing on the web today, actually, right? You have access to the camera API, you get your basically buffer, you convert that to WebP and send that back up. So, if you're trying to upload WebP to, I don't know, Flickr, right? I don't think I've actually talked to Flickr, and we have a conversation with them, but they don't currently support it. So if you just throw that out Flickr, they'll say, I don't know what idea.
I don't know what you're giving me.
Right.
Yeah, exactly.
What about OS support for WebP? I mean, if people download it from their browsers and they view their images, do they need to download the codec for the OS as well?
So that's a good question. So on Windows, we actually provide a plugin.
There is a plugin, and for OS X, there's a third-party plugin that does the same.
Yeah. So unfortunately, it's not native. Like if the user just drags in the file, right, they'll just have they won't be able to view it. But there are plugins for both platforms. And is there anything for Linux?
I believe so. Yes. If you go to the Wikipedia site, there are definitely viewers.
So actually, that's a good point. Go to the Wikipedia site, and you can download those plugins.
Yep.
And I hope, as we said, we're going to make the tooling better in 2013.
Yep.
All right.
Okay.
I think that's it.
Yeah.
Awesome.
Awesome.
Thank you, guys. Thanks, Steven.
Thank you, Ilya.